Okay, hello my dear students. Assalamu alaikum to everyone. I think all of you are fine and safe, staying at home. And in the last class, I discussed chapter 3, a topic on force, and we discussed three things related with force: inertia, force, and motion. These 3 points I discussed in the previous class. Today we are going to discuss a new topic on this chapter. Okay, and after knowing this lecture, if you have any question, then you can write to me to my email address tsz73uddin@yahoo.com, or you can text to me at 01727103811. Okay. Okay, today what I am going to discuss, I will first show you some video clip, then you will know what topic I am going to discuss. Okay, so you are going to see the topic that I am going to discuss. You find, let us see a small video clip.
Impulse of a force. In case of a ball hit by a bat or driving a nail into the wooden block with a hammer, the force acts for a short time interval. This force varies with time, hence cannot be measured easily. In such cases, we measure the total effect of the force called as impulse of force. Consider an impulsive force vector F acting on a body of mass m for short time t. The velocity of the body changes from vector u to vector v. According to Newton's second law, vector F is equal to vector p2 minus vector p1 upon t. Impulse of the force or impulse vector F dot t is equal to vector p2 minus vector p1, that equals to vector j, that equals to m vector v minus m vector u. This shows that impulse is equal to the change in linear momentum of the body. Impulse is a vector quantity. Its direction is same as that of the force. The SI unit of impulse is same as that of linear momentum, that is kg meters per second or Newton seconds. Dimensions of the impulse are L raised to 1, m raised to 1, t raised to minus 1.
Let us see another video clip. So my dear students, today I am going to discuss momentum, which is related with Newton's second law of motion. So I will discuss both of these, Newton's second law of motion and momentum. Okay, what is momentum? The quantity of motion of a body is called momentum, and mathematically we know the product of mass and velocity is called momentum. And what about Newton's second law of motion? Newton's second law of motion stated that when a force acts on a body, it produces an acceleration in the direction of force, and the magnitude of the acceleration is directly proportional to the resultant force and inversely proportional to the mass of the body. Now let us discuss mathematically. Let the force be F, and due to the application of the force, the acceleration be A. So when applied force is more, then acceleration is more. But if mass of the body is more, then acceleration will be less. So acceleration is inversely proportional to the mass and directly proportional to the force. So we can write F proportional ma, and finally we get F equals to kma, where k is a constant and its value depends on system of units, and in SI value of k is 1. So let us consider a body of mass m moving with velocity vi, and if a net force acts on it for a time b t, it moves with velocity, then after time t it moves with velocity vf. So the initial velocity vi, final velocity is vf. So now we know initial velocity is vi, so initial momentum is mvi, and the final momentum is pf is mvf. So the change in momentum is mvf minus mvi. So the rate of change of momentum is m into vf minus vi by t, and vf minus vi by t is acceleration. So we can write acceleration A is vf minus vi by t. Therefore the rate of change of momentum becomes ma, and which is equal to Newton's, according to Newton's second law of motion, this ma is equal to the applied force F. So F equals to ma. So my dear students, now today actually our topic is Newton's second law of motion, and from Newton's second law of motion we will also discuss impulse of force. So finally, what we get from Newton's second law of motion? According to Newton's second law of motion, you write the statement that already I told. First you write what is momentum. The product of mass and velocity of a body is called momentum of the body, and it is a vector quantity. So if mass of a body is m, velocity is v, so momentum p is mv. Mathematically we use this expression. And now impulse of force, the product of force exerted on a body and the time of action of the force on the body is called impulse of force. Impulse of force is expressed by J, that's why J equals to Ft. So actually what is our topic that I am going to discuss? Momentum, and then impulse of force, after that I will try to make a relation between force and impulse. Then we will discuss Newton's second law of motion and its application, and then I will discuss Newton's third law of motion, and finally we will describe the conservation of momentum, law of conservation of momentum. So what is the Newton's second law of motion? You write the statement. The law of the rate of change of momentum is directly proportional to the applied force on it, and the change of momentum occurs along the direction of force. I repeat, please, you see Newton's second law of motion, the rate of change of momentum is directly proportional to the applied force on it, and the change of momentum occurs along the direction of the force. let us know deduction of F equals to ma. Let us consider a ball having mass m, moving with velocity, initial velocity u, then a force be applied on it. So initial momentum was p, initial momentum mu, initial momentum mu. When the force is applied, then the momentum is changed. As long as there is force, momentum will be changed, and the new momentum is mv. So what is the change in momentum? mv minus mu. But what is the rate of change of momentum? Let it takes time t to change the momentum. So the rate of change of momentum is mv minus mu by t. So F proportional mv minus mu by t. Then F equals to k into mv minus mu by t, where k is a constant, and this k is defined from the system of units. You know, here the quantities are mass and acceleration. Mass and acceleration. V minus u by t is acceleration. That's why F equals to m in ma. So the value of k depends on the unit of mass and the unit of force and acceleration. And we take the unit of force is Newton, and 1 Newton is that force when it exerted on a body of mass 1 kg, then it produces acceleration of 1 meter per second square. That's why if we put the value of m is 1 kg and acceleration is 1 meter per second square, then the force is 1 Newton. Then force 1 Newton, then we put the values of these three in this equation of 1, then we get the value of k is 1. That's why putting the value of k is 1, we get finally F equals to ma. Pause. Okay, my dear students, again I am discussing it on the board. Try to understand again so that you can clear your concept. Let a body of mass m and initial velocity is u, so our force is applied on it, then its velocity will change, and as a result its momentum will be changed. Let the force acting on it for time t. That's why after time t, let its velocity is v, so its momentum is mv. So I write initial momentum mu, final momentum mv. So the change in momentum is mv minus mu. This change, when we write any change in physics, then we use this delta. So delta p means change in momentum, and this change occurs for time t. So the rate of change of momentum, rate of change of momentum is delta p by t. That's why mv minus mu by t. So we take common this, and this part is acceleration. You know, from the chapter 2, v minus u by t is acceleration. That's why we get rate of change of momentum is ma. Rate of change of momentum is ma. Now from Newton's second law of motion, we get rate of change of momentum is proportional to applied force. Rate of change of momentum is proportional to applied force. So ma equals to kf. ma equals to kf, or you can write f equals to kma. Doesn't matter. The value of k is a constant. K is a constant, proportionality constant, and its value of k depends on the unit of mass, unit of force, and unit of acceleration. These three. So when we consider, when in SI, system international, m equals to 1 kg, and to produce acceleration what is acceleration? A equals to 1 meter per second square. The force required is called 1 Newton. That's why if we put these three values in equation 1, we get ma equals to 1 into F, that is F, and finally we get F equals to ma. In this way we can deduce F equals to ma. So deduction of F equals to ma. This is the process how we can get F equals to ma. I am going to discuss now Newton's another laws of motion Newton's another laws of motion, which is known as third law of motion. Newton's third law of motion. So first I will show you some examples of Newton's third law of motion. Then we'll discuss what is the third law.
There are a lot of things happening in the world. Objects move, fall, and rest all around us. You may think you understand why things move or don't move. But did you know that the forces acting on these objects can be measured and their motion predicted? Renowned English scientist Newton's third law of motion says that for every action, there is an equal and opposite reaction. If you exert a force on an object, it exerts an equal force back on you. For example, a ball hitting the ground exerts force downward. The floor exerts an equal force upward. This is the principle that allows rockets to launch or jellyfish to swim. By exerting a force downward, an equal and opposite force pushes upward, and the object accelerates. We can also see the third law in action when birds fly. Their wings press down against the air. The air pushes up against their wings, allowing them to move upwards. Another good example of this law is skateboarding. The skater pushes backwards against the ground with their foot. The ground pushes forward with equal force. Since the wheels of the skateboard reduce the friction between the person and the ground, they are able to move forward for some time before forces slow them down again. Although these three laws were written down more than 300 years ago, they are still in
Start. So now you know what is Newton's third law of motion. We see another video clip, so it will be more clear to you.
Till now, we've only learned the first and second laws of motion. Oh, you're riding a bicycle. Have you ever wondered why a bicycle moves forward? Well, it moves according to Newton's third law, which says that for every action, there is an equal and opposite reaction. To understand this, see what happens when you drop a tennis ball. As the tennis ball hits the floor, it causes a downward force on the floor. This is the action. The floor reacts by pushing on the ball with the same force, but in the opposite direction. Action, reaction. Together, the floor and the ball form what's called the action-reaction pair. So now how it applies to your bicycle. When you push the pedal, the parts of the tire which touch the ground push it backwards. The ground also pushes the tires forward with the same force. So the parts of tires and earth form a pair of action and reaction. So what happens to the earth when your tires are applying force to push it backwards? Huh?